Thank you and good morning. So, as you've heard, I represent today the members of the International Geothermal Association. It's currently 25 associations of 23 countries representing 5,000 members. And today what I'm going to talk about is a snapshot of where the geothermal world is today, as well as a forward look as to where it perhaps may be going. And I'm going to concentrate on electricity generation rather than on direct use today. So I've divided my talk into three parts, where we are currently, what new things are happening in geothermal today, and I'm also going to, in talking about where we may go in the future, take a bit of a look as to where the frontiers of development of electrical generation of geothermal are today, and in particular the use of lower temperature resources. Now often when I talk about this subject I also include a discussion of EGS, enhanced geothermal systems, which is certainly part of the future of the world geothermal scene. I'm not going to do that today, however, because I know that Jeff Tester is here and I'm sure he's going to cover that subject at length later here in the conference. So I won't talk about EGS today except in passing. So let's talk about where we are today. I'm going to give a few remarks about the United States, which is where I happen to be from, because that's the numbers I have closest to me, but I will expand on that a little later to talk about the world in general. In the last decade, up until 2010, the world in general, and the United States in particular, these numbers here are for the United States, have seen a very substantial increase in the generation of electricity from renewable sources. So you can see here that over the last 10 years until 2010, there's generally been a reduction of the total energy output from hydroelectric, mainly because of silting of dams and storage lagoons, but an increase in the other renewables. That's wind, solar, biofuel, and of course also included there is geothermal. Not often understood, I'm sure by everybody in this room, but not often as well understood outside this room, is that there is a distinction between the renewable sources, and geothermal is almost unique, not quite, but almost unique in its ability to provide base load renewable power. And it shares that with other conventional resources like nuclear and coal, but among the renewables, only biofuel and geothermal have the ability to run 24 hours a day, 7 days a week, 365 days a year. Furthermore, the emissions, the life cycle emissions of geothermal power are significantly lower than most sources. You'll notice in here, perhaps surprisingly at first, that there are carbon consequences of wind generation, and for that matter even greater in the case of solar photovoltaics. Those carbon emissions don't come from the generation of power, but from the manufacture of the devices themselves. And what you see from this slide is that the life cycle emissions from geothermal are, together with nuclear and with wind, the lowest of all of the available or the widely available resources we have today. Now, speaking on behalf of the IGA, let me draw your attention to some numbers that occur on a 5-yearly basis. Every 5 years, the World Geothermal Congress is held. It's organized by the IGA. And we might imagine that to be a kind of a geothermal Olympics. Every 5 years, the geothermal world gathers and talks about what they've been doing. And one of the functions of the World Geothermal Congress is to conduct every 5 years an inventory of all of the resources on the planet, those that are in production and then those that are expected to go into production. So in 2005, in Antalya, Turkey, when we met for the WGC, the numbers were collated. You see the numbers shown here, published in a paper by Bertani. So in 2005, 8,900 megawatts was currently under production at that time. And the figure on the right that I pointed out with the red arrow, 10,738, was the projection at that time in 2005 of what the output would be in 2010. So people were talking about what they had in development in 2005. So remember that number, 10,738. So the question will come then, well, what actually happened in 2010? So these are the similar numbers from the WGC 2010 in Bali, Indonesia. And what you see here is 10,715 is what was actually in production in 2010. The difference is about 20 megawatts. So the important message that I want to convey here is that we, the geothermal community of the planet, met our promises between 2005 and 2010. What the developers said they were developing was in fact developed between 2005 and 2010. So if we look ahead to the projection that was made in 2010 to where the geothermal world will be in 2015, the projection in fact is 18,500 megawatts. So that was 2010, so we're now in 2013, so let's talk about what's been happening more recently. We don't yet have 2013 numbers for the world, but we do have 2012 numbers, not from IGA, but from GEA, the US organization. And what you can see here is that we had reached in March, the early part of 2012, we had reached 11,224. That's clearly, to anybody following the numbers, falling behind in a projection toward 18,500. That's largely the consequence of the financial crisis of 2009. Nonetheless, we are still moving forward. Looking at the installed capacity in the United States, this does include 2013 numbers. So in 2012, the US was at 3,187. In 2013, as of February 2013, 3,386. So the US increased its geothermal production of electricity by 5% between 2012 and 2013. And presently, the United States in particular has 147 independent geothermal projects that are underway. What you can see, the largest section of this pie chart, conventional hydrothermal resources unproduced, those are geothermal developments in places not previously developed. So these are new fields. The lighter colored blues are developments in existing fields, expansion or redevelopment. And then finally you can see co-production and the smallest one at the top, EGS, Enhanced Geothermal Systems. Now I added this slide to my talk. President Obama gave his State of the Union address last week or the week before, and so I borrowed one of his slides. So I pay his salary, so I think I can do that. And what you can see here is that the total renewable generation in the US over the last 5 years has doubled, and importantly, you can see the component there of geothermal. The blue is wind, the red in the middle is solar, and the amber color on the top is geothermal. This is important for two reasons. It's part of an upswing in general to renewable energy, but more important is the fact that President Obama showed a slide that had the word geothermal on it. And that's a very significant political event in the United States. You here in Iceland have a president who understands geothermal very well and speaks about it eloquently and frequently. However, in the political circles in the United States, geothermal is not a well-known word, and the fact that it's now being discussed is very significant to the future of geothermal in that country, the US. Looking ahead, this is again the US figures. You can see that geothermal projection is significant. It lies behind biofuel and wind, but it lies ahead of solar for the foreseeable future in the United States. Now, let's talk about other countries too. New Zealand is another important geothermal country. It has an energy present shown and past shown in this graph. And what you can see is a very substantial increase in the geothermal production in New Zealand over the last few years. And importantly, what you can see, comparing the geothermal, which is the purple bar, with a yellow one, which is natural gas production, and the light grey one, which is coal. Geothermal is basically substituting for fossil fuel generation in the United States, in New Zealand. So much like Iceland, a large fraction of the electrical production of New Zealand is coming from renewable sources, and that fraction is going to increase. This is the same graph I borrowed from Chris Bromley in New Zealand, but I'm showing it because it shows the projection to the future that the previous one showed only the numbers. And importantly, I'd point out here, this is a complicated graph, but these two numbers here, this 10% is the projection for 2016, 3 years from now, of the fraction that will be produced by natural gas, and 23% is the fraction that's going to be produced by geothermal, which is a very large increase in fraction as well as a very large amount of actual power. So you see this graph yesterday. This is a case of Iceland, in which for primary energy, the largest fraction by far is geothermal. And importantly, let me just make the point that the geothermal world is not standing still. This is a picture of a plant, a 110 megawatt plant installed in Indonesia last year, started up in October 2012. There are new geothermal plants coming online across the world everywhere today. This is another example in Kenya. Kenya has undertaken a very aggressive development program for geothermal energy. They anticipate, with plants under construction, to have 560 megawatts online by 2016 and 5,000 megawatts online by 2030. To put that in a small amount of context, a number not shown on this slide is the current electrical generation of the nation of Kenya, which is presently 1,400 megawatts. So what you see with these two numbers, that the development of electricity, as well as, if you like, the industrialization of that country, is going to be fueled by geothermal electricity. And I added this slide also over the weekend. This is as of February 27th, a TV program being produced by CNN. Actually, it's about the developments in the Philippines. I don't know, do you have CNN in Iceland? What we say in the United States is once it's on CNN, then it's real. And therefore, this is an important event that CNN is making TV programs about geothermal and making the comment that you see there at the bottom. All right, let me switch to my second topic, how things are changing in electrical production. Up until a few years ago, most of the geothermal plants that we saw across the world were more or less the same, or at least very similar. They used very similar technologies. They had very similar configuration. Almost universally, for example, most of the geothermal flash plants across the world had inlet pressures of order 600 kilopascals, about 6 atmospheres. And the steam consumption of the geothermal turbines that we've been using for the last 50 years or so are in the range, it varies from place to place, but 8 to 10 kilograms per kilowatt hour generated. Nowadays, however, in the last 10 years, we've seen a lot of different kinds of innovation applied in the geothermal field. And nowadays we have turbines with steam consumptions as low as 5 kilograms per kilowatt hour, largely achieved through higher inlet pressures, achieved through hybridization of flash and binary plants, combined cycle plants, as well as innovations in the plants themselves. I'd also like to show some other kinds of hybrids with other renewable sources. In particular, I'll talk about two. There are others to talk about, but I don't have time today. This is a combined hybrid of solar thermal and geothermal in El Salvador, in which they're kind of raising the temperature of their water. This is the cycle. They're raising the temperature of the separated water to produce additional steam using solar thermal. The second example, this is a hybrid solar geothermal plant in the United States, in Nevada. This is photovoltaic solar, which surrounds the geothermal, there's a binary plant that you see there in the center. And that has the advantage of two things. First of all, it makes use of the land, which is the geothermal plant is obliged to take up for its well field. And secondly, in a place like Nevada, which is very short of water and is therefore obliged to use air condensers, the plant efficiency is extremely low in the afternoon. I don't say extremely low. It's lower in the afternoon when the temperature is hottest. That happens, unfortunately, to coincide with the largest electrical load from the grid. So adding photovoltaics allows them to backfill the lowered efficiency of the air condenser in the afternoon and provide a more stable power. So in this case, they've added 24 megawatts of solar to 47 megawatts of geothermal. So my third topic then, as I come towards the end, is frontiers, places where we're developing geothermal resources at lower temperature. This picture shows the resource in Chena Hot Springs in Alaska, which probably is the lowest temperature that anybody is producing electricity in the world today, at 74 degrees centigrade. Chena, Alaska is famous and important because it's a small community which is 90 kilometers from the closest power line. And therefore, up until they installed this geothermal plant, they were trucking diesel fuel into that community to generate electricity. Instead of doing that, they are using their resource from the hot spring itself and providing 300 kilowatts for their own consumption. And there are many places in the world where that could be useful. Island communities, such as in the Caribbean, isolated off-grid communities like that one in Alaska. But not only those. An important application we heard about yesterday in Japan from Dr. Yasukawa is making use of the hot spring water in the onsens or natural hot spring spas for generation of electricity. And that's important because the hot spring community in Japan is generally antipathetic to geothermal electricity development. They don't like it because they think it's going to detract from their spa resources. However, once they learn that electricity can be made available from their excess heat, then perhaps they can change their point of view for opposing geothermal development. And then finally, we have a lot of water production from non-traditional, or I say non-traditional sources of geothermal water, in particular from oil field waters. Perhaps you know this, that the world is currently producing 95 million barrels a day of oil, and accompanying it is 300 million barrels a day of water. So oil companies are in fact water companies, and they produce a bit of oil along the way. And in many places that water is of sufficient temperature to be of geothermal interest. So this is an example of a geothermal field making use of oil field wastewater in Rocky Mountain Oilfield Testing Center, the infamous Teapot Dome oil field, where they have water at 92 degrees, and they generate 200 kilowatts of electricity, which they use on site for the pumping units of the oil field. This is a second example in Huabei oil field in China. They have two different reservoirs there at different temperatures, 110 and 120 degrees, which they combine and use in this binary plant producing 400 kilowatts. And they presently have a second unit under construction in that field. And thirdly, the co-produced water doesn't have to be associated with oil fields. This is a third example in Neustadt-Glewe in Germany, where they're taking heat from water produced for district heating and using it to produce electricity as well. In this case, 99 degrees is the temperature of the water, and they're producing 200 kilowatts in combination with the 6 megawatts thermal that they were previously using for district heating. So, drawing to a close then, since the 2005 period, the last 5 to 8 years, there's been significant changes in the geothermal world. I refer to it here as a renaissance, a rebirth of interest in geothermal production, as well as a lot of new ideas that have been applied. Not only new ideas, but also new players. There are countries producing electricity now from geothermal sources that didn't previously, and there are new companies that have formed to make use of those developments. Technologies are being applied now that weren't previously used, and furthermore, we're moving into frontiers, thermodynamic frontiers for geothermal development, producing from resources that were previously considered too low in temperature. And as I mentioned as I started, I haven't talked about it today because I know it's going to be talked about elsewhere in the conference, but EGS, in fact, Enhanced Geothermal Systems, provides another area of advancement. And I would point out that as of 2010, accounted for in the WGC, at that time, combination of electrical generation and direct use was the equivalent on an annual basis of 239 million barrels of oil. So that was geothermal application that avoided 3 days' use of the planet's production of oil. So that was oil available for other uses, and more importantly, the carbon offset of that also corresponds to 3 days avoidance of oil production. And I'd like to close. I mentioned twice our Geothermal Olympics, the World Geothermal Congress. The next one will be in 2015 in Melbourne, Australia. And I hope that many of you will be inspired to go there and participate in that event. Thank you very much.